All right, now we're going to talk about hemispheres. And hemispheres, some people kind of jump to a certain conclusion about hemispheres and how the surface area works. So I want you to be really careful. I'm going to do a long, drawn out explanation, but then I'm going to also show you what the shortcut is or what that long explanation leads you to a very simple formula. So most people think that the hemisphere is just half of a sphere. But if you think about if it was a solid hemisphere, it would have a base. So thinking about if you took a basketball and cut it in half, it would be hollow on the inside. So it's not a solid object. And so with a hemisphere, it's that half of a basketball, but it has a solid base that where you cut that hole is filled up. So there is a circle there now, going right through the center of your circle, through your sphere. And so this is half of a hemisphere or half of a sphere. So your surface area is 1/2 of a sphere, which is 4 pi r squared. That's true. That's covering kind of the lateral, if you want to call it that, part of the surface area. And then the base, this is our base down here. This is a base. What shape is that base? It's a circle. So plus the area of a circle, which is pi r squared. Now, if I simplify this out, 1/2 times 4 is 2. So 2 pi r squared plus pi r squared. I can combine these because I have pi r squared in both of them. And so the surface area for a hemisphere turns into 3 pi r squared. So like I said, most people jump to the conclusion that it's just half of a half of a sphere, but it is half of a sphere plus the base, which is the circle. So you have to take into account it's half a sphere, 1/2 a sphere, plus area of base. So 3 pi r squared. It is not 2 pi r squared. It is not, it is not, it is not. Get that out of your heads. It happens every year. All right. So if I look at an example, I have a hemisphere with a radius of 5 inches. I have a radius of 5 inches. So my r is 5. Surface area of a hemisphere. We don't have to do this long drawn out presentation. You can just use 3 pi r squared. So 3 pi, my radius is 5 squared. 5 squared is 25. 25 times 3 is 75. So 75 pi inches squared. 75 pi inches squared for that hemisphere. Okay, let's look at just a few more examples before we get to our composite having to do with hemispheres and spheres. So our next example says a hemisphere has a base with an area that is 49 pi. So the base of our area is a circle. So pi r squared equals 49 pi. So what is my r? What is my r? Remember, r squared has to be 49. So r has to be 7 inches. So now for surface area, we take 3 pi r squared. 3 pi r squared. 7 squared is 49 times 3 gives us 147 pi inches squared. So there I was given the area of the base, I was given the area of a circle, and I had to derive the radius in order to find the area of our total surface area. Okay. And last little quick example here. Find the radius of a sphere with a surface area of 100 pi. So it's a full sphere, so that's 4 pi r squared. So we're just going to set these equal to each other. So surface area equals 100 pi, which is 4 pi r squared. I'm going to divide out 4 pi. The pi's cancel out, and my 4 is going to turn that 100 into something else, 25. So then we're left with 25 equals r squared. So our radius is 5 units.